All right, I'm going to do a little bit of a different approach on this video. I'll maximize this when I start doing work. But lesson 10, this is Math Balls, Unit 9, Lesson 10, um, joint variation. These problems take a little bit more work, and I think I need the whiteboard to really do the full problems. But what they're going to do is they're going to set up a situation where you have a combination of direct and indirect variation. So I'm going to kind of walk us through how we do this. So it says in this first problem that the volume of the gas directly varies. I'm trying to move this over here and see if this is a better spot for it. Hopefully I can do it at the same time. Yeah. All right. So the volume of the gas varies directly as the temperature. So volume. That's bad markers. Switch out markers here. So volume directly means the temperature is going to be on the bottom, and inversely as pressure. So that means pressure is going to be on top. Because remember, direct means they increase the same, and inversely means they're being multiplied by each other. So this is what we have. And more than that, they actually tell us the values for some of that. They tell us that if the volume is 50, that's this, and the temperature is 300 K, and the pressure is 20. So what we really are finding is that this is how you find the K value of this function or of this variation. So we'll go ahead and do that. 50 times 20. 50 times 20 divided by 300. Divided by, nope, still not working. Divided by, there it is, 300. I'm going to make my thing a little smaller here. Okay, and I get this number here. So K equals 3.33 about. So we'll leave it like that. All right, so then what we're going to do is we're going to go to the next problem, and we're going to, next part of the problem, and it's going to be one of these values missing. So we'll jump over here. It says, what's the volume? That's the thing we're looking for. When the pressure is, so the temperature is 270 and the pressure is 30. So it's saying, what is the relationship here? So in order to solve this, we just have to solve, again, we're trying to solve for the V. So that's what we want to get by itself. So to do that, we're going to multiply times 270 over 30, the reciprocal. So we're switching. You see how the 30 goes down, the 270 goes up, and we do the same thing on the other side. We're going to multiply this times 270 over 30. Sorry about the small writing, but just understand we're multiplying both sides of the equation by this fraction, 270 over 30. So let's go do that. So we're going to take 3.33, and we're going to multiply it times 270 divided by 30. And we get 29.97, which is probably actually 30. But let's look. And there it is, 30 cubic inches. So notice that was because we rounded 3.3. And that's why we didn't get exactly 30. You would have if you had not rounded this. So that's more or less what you're doing. These are a little bit tough, but let's look at one more and go over it together. So this problem says that y varies directly as x and inversely as z. So we get yz over x. And it says in this situation, we have 25 for y, we have 3 for z, and we have 5 for x. So we'll solve that. 25 times 3 divided by 5. So we get 15. So we come down and we say 15 equals, and then we fill in the next situation. Find y when X equals 10. That's the denominator down here, 10. And Z equals 25. So again, we're going to multiply times 10 over 25 so that these cancel out. And we're going to multiply this times 10 over 25. So we'll go back over here, and we'll do 15 times 10 over 25. We get 6. Okay, and that's pretty much it. Only difference is when it says varies jointly. When it says varies jointly right here, the difference is that you're going to set up the equation as this. K equals y x. Actually, let me erase that. That's not right. Y equals, or y divided by x and z. So it's just set up differently. So you're doing this as your new equation. Do the same thing you did here, except both x and z are in the denominator. And then you solve, just like we did on the previous problem. That's the same with number 5. Number 6 is going to be another specific situation. So let's look at it together. It says wind resistance. So we'll say that's W. Wind resistance varies jointly as an object's surface area and its velocity. So notice it's jointly, so S and V are in the denominator. Then it says we have an object traveling 60 miles an hour. That's here, 60. With a surface area of 15. Experiences a wind resistance of 200. So then we're going to solve for this. 200 divided by 15 times 60. And we get 0.222. So let's just put that down. And then 0.222 equals, and then we fill in the new values. It says a car with 45 square feet of surface area. So that's 45. That's the surface area that's down here. And it's going to experience 250. So the question is, what's the velocity? This one's a little bit different because we're going to have to cross multiply to solve. So we're going to multiply, this is over 1. So we're going to multiply these together and multiply these together. So this 250 times 1 is 250. We need to do 0.222 times 45 times 45. We're going to round that to 10. It's pretty clear. So it's 10 V. And then we're going to divide both sides by 10. That cancels. So V, put it over here, V equals 250 divided by 10 is 25. So that's got to be our answer there. There it is. So that's going to be similar to what you have in number 7 and number 8 and number 9. So all of those are going to be like that one. And then we'll move on to Unit 10.